My name is Justin Horton. I'm a software engineer at Workday. I'm joined later on in the presentation by Tomasz Sabo, who is an engineer at Itemis. He is a co-contributor to this plugin, and he's also helping Workday build our MPS IDE and languages. And today we're going to be talking about a code reviewer plugin we've built to help improve MPS pull request workflows. Do keep in mind that this is something we've built in about a month or two. So it's still a bit rough, but we're excited to show it to you today. I'm just going to show this because better safe harbor than sorry harbor. Just to give a quick background on Workday and our usage of MPS in our languages. So as Matt mentioned yesterday, Workday builds a variety of enterprise software applications such as human capital management, payroll, financials, and many others. And for over 10 years, they've been built in a language called Expresso, which is a high-level, form-based, metadata-driven language that's built in browser, and it values clicking and copying and pasting over typing. In mid-2016, we started building YP in MPS as a replacement for Expresso. And our goals there were, first of all, to improve application performance by providing a lower level optimizable AST. And secondly, to improve developer productivity by providing a language that's both easier to learn. As Nat mentioned, Expresso usually requires a 5 or 6 week boot camp to even get started. Both easier to learn as well as more productive once you do learn it, as in you can physically code it faster. It is a relatively general purpose language, but it provides some built-in constructs for things we commonly do within Workday. And after all, we did have a lot of Expresso code already, so off to the right, you can sort of see how we manage this. Expresso itself has an underlying AST. Of course, MPS has an underlying AST, and we compile those to a shared runtime AST that we've defined in Java. And by doing that, we can interpret and optimize that runtime AST relatively independently of the source language. Right now at Workday, we have multiple teams implementing DSLs. Our core team has built 3 DSLs in the past year and a half, and we now have 2 other more external teams starting on their own integrated DSLs that work with our core languages and IDE and shared runtime framework. We are beginning language adoption. Right now we have around 40 people working with this every day as part of their daily job. And so far the feedback has been overwhelmingly positive. Again, as we joked about yesterday, the alternative is kind of horrible, so it's not too much of a surprise that people like this better than Expresso. However, the main feedback we've gotten is with the projectional editor, where people will type things that are very clearly red on the screen, not red squiggly underlined, but just completely red, as in not bound in the model, and think that that should work, and it doesn't work. We do have a rapidly growing MPS dev team from around 4 developers a year ago to around 15 now. And we do expect that to grow quite a bit over the next year. In addition, we expect, based on our current language adoption, that we'll have around 400 application developers by this time next year using our tool and language. So now I'm going to jump into the problem we were having that inspired this plugin. So in our early days of MPS development, we had a fairly small team, just a few developers. It was really easy to keep in sync as to who was working on what and roughly how it was being implemented. So when it came time to open a pull request, well, there wasn't a whole lot to review because we already knew what was going on. So we didn't have to spend a lot of time in that feedback phase. However, as our team grew and we hired more developers who had no knowledge of MPS, as most developers in California don't have knowledge of MPS, we found that that team growth meant we were spending a lot more time on pull request feedback. And sometimes our reviews would be multiple iterations, meaning the reviewer would have to go in and pull down that branch repeatedly and make more feedback. And this is when we really started to notice the deficiencies of the standard pull request when paired with MPS projectional sources. So we found we were spending a lot of time context switching between MPS and the pull request, and further, since MPS doesn't have any meaningful line numbers to reference, we were having to use manual effort to like associate those specific comments with some particular node in MPS. And as you can see from these screenshots here, the first way we did this was sort of by like actually describing the node of interest. So we might stick it on the right root node. We're using file per root persistence. So we might stick it on the right root, but in like the language aspects, there's still just one big file. And like something like this, the type system, or yeah, this type system operator overloading DSL is a bit hard to like pinpoint which node you're talking about. So we had a couple of approaches to try to improve this. First of all, we started using the MPS node URL feature to provide some consistent way to identify the nodes we were interested in, and obviously identify arbitrary nodes there. And before that, we were using the embedder HTTP support feature. And but as you can see, there's still like a multi-step process to go in, view the projectional diff, go into the normal editor, copy that link, and paste it back into Bitbucket, which is our pull request tool. Secondly, we provided a linter plugin, and actually I forgot to mention on the last slide that our pull requests were being kind of polluted by a lot of comments regarding stylistic issues. So normally in like a Java code base, you'd have a tool like checkstyles that runs on that code. Of course, you can't do that against generated MPS code, or it'd be a horrible result. However, so we were making those sorts of comments on the pull request, just not really core to the feature. And what we provided instead was a linter plugin in which we defined certain stylistic checks that we cared about. And prior to opening a pull request, the developer can go in, run the linter against the project, and then just click perform quick fixes, for which we've defined model transformations that will actually make your AST abide by the styles we've specified. However, this still wasn't quite good enough for us. We were still spending a lot of time context switching between MPS and the pull request. And so we started looking at what existing tools are available. And first we looked at the embedder code review tool. And what we liked about this tool is that it allowed inline commenting within the MPS editors. However, what we didn't like is that it stored that review information along with the model itself. So for our pull request-based workflow, that would mean that reviewers would have to make changes to the model, commit that to the pull request branch, and the developer would have to pull in those changes to have that review information reflected in their own copy of the branch. So we also heard about a Bitbucket plugin that took screenshots of the MPS projectional diff and posted those to the pull request. However, this mechanic itself was a deal breaker for us, because one of the key things we wanted to get out of this was inline commenting within the projection. So we decided to build our own tool. And the main things we wanted were inline commenting within MPS in the editor and storing the feedback along with the pull request instead of the model itself. And here's what we came up with. So this plugin allows you to post feedback within MPS and optionally associate that feedback with particular MPS nodes. The feedback itself is distributed via the pull request, so whatever pull request tool you're using. And you can view feedback inline within the editor, and we achieve this with Embedder's conditional editor. Their stuff is great. You should use it. We do use grammar cells, actually. Why would anyone not use grammar cells? And the plugin also mirrors other important pull request information, such as the description, who approved it and when, and the branches involved. And the goal of this part of it is that we want to minimize the amount of context switching you have to do between the pull requests and MPS, because after all, to really do a meaningful review, you need to be able to visualize the projection. So we want to keep as much of that in MPS as possible. And Lastly, and maybe most obviously for all of you who know how this stuff works, it works with any MPS DSL. There's no configuration necessary in your language to set this up. And now I'll hand it off to Tomasz, who will give a quick demo as well as an overview of the plugins architecture.
So does the yeah, it works, I guess. All right, so I'm gonna switch over to MPS and show you this code reviewer plugin in action. But actually, before doing that, I want to actually go to Bitbucket to show here this pull request. This is a long-standing one that we have created. It's introducing some machine learning into the Workday code base, and this is about this well-known Bayesian algorithm which we want to integrate sooner or later. And I just want to quickly show what is the pain that we are going through in this pull request and the reviewing. So I mean, this diff is not really interesting, but what I want to show is what I want to say is that experienced Workday engineers, they developed this awesome skill that they could parse the persisted MPS files, and then they actually, when they wanted to write a sophisticated code review, they actually figured out what is the line in the XML file where they should attach the comment, so that it can be traced back to an actual MPS AST node. And it is amazing, but new engineers are struggling with this, and that's why we want to help them. So there is this pull request here. It has already some activities, like people commented on it that it's nice or it needs more work. So for example, here Tyler said that it needs more work. And so inside MPS, I have already installed this plugin, and it comes with this separate tool window. This is the reviewer tool. And you see here that I loaded this AI pull request, and it shows all the details. So we have here these comments. There are also the other activities like marked as approved, that the pull request was opened, it needs more work, and so on. It also shows here that what is the branch for the pull request and what is the other branch that we want to merge this into. And it shows the pull request state that this is open. Here's the author of the pull request, and then the description about the Bayesian stuff. Now, an interesting thing is that, so I can write a general comment here in this text field. So I can say that this looks good to me, and then I can comment on the review. So when I do that and I go to the web page, then once I refresh the Bitbucket page here, then here's my comment. And this also shows up here in the view. So there is now a new text box, this looks good to me. Another thing is that somebody already commented on an actual line of code in MPS that, for example, it needs some optimizations. So we can click on this navigate button here to actually navigate to the respective part of the code in MPS, which the comment is about. And you can see here that we already have this nested comment view enabled. So we use a simple node attribute for this. The comment appears as a node attribute, and then we use a conditional editor to replace the editor of the original AST node and then add this custom swing view to show the comment. Another thing is that I can also do myself a comment like this. So I can select here a piece of code. Like I say here that this should be called whatever. Please rename. And now I choose the other one, comment on node. So when I do that, then let's take a look what happens here. So you see here that beyond my comment, there is also this node pointer. We just realized that it would make sense that we use here this node URL that MPS provides so that you can actually click on this one here. As said, this plugin is a new kid on the block, so we are working on this. So also here, this activity view was refreshed. So now here's my comment, and just like with the others, I can click on this to navigate to the corresponding node. And also once I refresh the editor, then my comment shows up as an inline comment here. Now you may ask, like, how did the reviewer plugin know that actually this is me who commented? So the thing is that on Bitbucket and also on GitHub, you can generate a personal access token. And this access token, we have a preference page inside MPS where you can specify this access token. And this is not necessarily, not really a secret information. It's not like that you should send it over to somebody else, but you can easily revoke it. So it's not going to be a problem if you share it with somebody. Also, it's not like that it's persisted in the repository. So this is an MPS project-specific setting. That's how we store it. And so using this personal access token, Bitbucket can figure out who is the guy who is commenting on the given pull request. Okay, so a few words about the architecture. I'm really not going to go into a lot of details here, but I think like just to position how this fits into MPS. Sorry for that. So this is MPS here, the blue stuff. We have this the version control server, Bitbucket or GitHub. So currently we have integration with Bitbucket only, but we designed the interfaces in a way that it should be easy to also integrate GitHub and potentially other version control systems, but these are the two that we had in mind when we were designing these interfaces. So the thing is that both of these systems, they have a REST API to communicate with the server, and then you can ask pull request information, you can comment, you can delete commands, reject a pull request, and so on, all kinds of things. The thing is that they communicate through a REST API, and they are sending JSON messages back and forth. So we get a JSON message, we use the Google JSON library to parse that, and then we interpret this information. There is something here which is called the Flux application. I will talk about that in the next slide. You can see here that the other end, this is what I was talking about, that there is a personal access token. And whenever we communicate with the server, we are also creating JSON messages, and that's what we are sending over the wire. So what is Flux? So Flux it's a Facebook invention. When we were started to develop the UI part of this tool, first we were thinking about like a traditional model view controller architecture, but it soon became pretty hard to keep track of like where messages are going between the UI components, because there are a lot of UI components here, like the activity store, we have a nested comment view, a main comment view, all kinds of UI components. And then we have also the corresponding business logic behind it, storing the activities, storing the commands, storing the pull request information, and so on. So I'm not going to go into a lot of details, like why Flux is better than the standard MVC. But I just want to recap like the main components, and then you can read up on it if this is interesting for you. So in Flux, the most important difference between a standard MVC is that there is unidirectional data flow. So messages are only flowing in one direction. It's not like that there's a store and there's a view and then they communicate back and forth. Every message goes through here, the dispatcher, and the way of communication is through actions. So whenever you want to change something in this architecture, you send an action. So there are actions here and there are actions there. So let's first talk about these actions. So these actions are triggered by UI components. These are like the activity store, for example, because I want to reject a pull request, I want to send a comment. In that case, I create a new action. Actions then flow to the dispatcher, and then there are these stores which essentially responsible for storing the business logic and the business data. And then stores register callbacks in the dispatcher, and then the dispatcher knows that for which actions which store is interested in, and then it essentially distributes those actions to the respective stores. Now the stores update their internal contents, and then the views get notified, and then they can just query the store about the required data. Here, this action on the left, it's also possible that, so typically actions are triggered by some user interaction, but it can also be that actions also occur in the system because of some asynchronous web call or some WebSocket that is running in the background. So these are the actions here on the left-hand side. Now just to instantiate this architecture for our system, like what kind of actions we have. I mean, I'm not going to go through all of them, but I already mentioned that there are actions like posting a command, deleting a command, approving a pull request, and so on. With respect to the stores, as I said, there are stores for storing activities, pull request information, and for example, the contents of the nested comment view. And then we have UI components similar to what I just said, like the nested view, the main view, and the activity stream. One interesting implementation detail that I want to mention is that it was pretty tricky to get this code reviewer work with the Git for IDEA plugin, because the thing is that this code reviewer plugin, I mean, the envisioned way of using it is that you install it into your MPS installation. And then this code reviewer plugin actually listens to the branch which you are currently on, and then it tries to look up the pull request on the respective server if there is any. And now this code reviewer plugin needs to listen to the branch changes. For that, we wanted to reuse the Git for IDEA plugin from MPS, but the technical detail is that the Git for IDEA plugin is an IntelliJ plugin. So if you're familiar with the details, then you know. If not, then I'm telling you that it's tricky to use that because the class loader mechanism is different in MPS for IntelliJ plugins. And then actually Alex helped me out, so thanks a lot for that. He actually created, he has a GitHub repository where it is demonstrated how you can make use of IntelliJ plugins inside MPS. And the only reason why I'm saying this, because if you end up with the same situation that you want to use something from IntelliJ, like Git for idea, the model checker jar, and so on, then here's an example that you could reuse. Okay, and I'm going to hand it over back to Justin to conclude with the presentation.
All right, so how are we going to evaluate this plugin? Well, first and foremost, we've open sourced it at Workday's public GitHub. You can find us at that link. We'd love to have you contribute, check out the project, see what you think. Do keep in mind, as I think we've mentioned a couple of times, that it's still early stages, so it won't be your perfect tool yet, but we do hope it will grow to be one. We're going to start using this for MPS dev teams within Workday, our internal team of around 15, and then we'll extend that on to language consumers, which, as I mentioned earlier, over the next year we'll have hundreds of those using our IDE. And lastly, of course, we'll incorporate feedback from all those sources and iterate on the design and features. Future work for this, we would like to imminently support GitHub. That seems rather obvious. Yes, we do sort of see the irony in hosting the plugin repository on GitHub, but only supporting Bitbucket. Seems silly. We would like to add support for other pull request actions, again, keeping with the theme of not having to context switch very much between the pull request and MPS, where you actually need to be to do the projectional review. We'd like to improve the commenting and refreshing user experience. There's some sort of weird interactions with the editor as we're trying to update those custom components and needing to refresh certain things. And lastly, we'd like to make it prettier by replacing Swing, which is terrible, with JavaFX or a web view, and by rendering markup and potentially images and attachments that come from your pull request. So just to summarize quickly, we've built a new code review tool for MPS that provides tight integration with the projectional editor. We did this because our workflow was horrible and we wanted to help ourselves, and hopefully this can help others as well. We would love it if you'd come check out our GitHub page and see what you think of the project. And definitely, if you'd like to contribute, get in touch with us on the page or by emailing me or Tomasz. Thank you. Yes. Okay. The question was, how much effort did we put into this? This is about a month or two of actual development work, about a year of frustration, imagining what we might do, and then a couple months of actual work. Yes. So the only dependency, sorry, what are the dependencies of the plugin? So I think we just have a handful of dependencies. We use Square's Akka HTTP to do HTTP requests, and we use JSON, and aside from that, I believe it's just the strange dependency on the Git for IDEA plugin. Oh, sorry. Embedder's conditional editor is another dependency. So yes, we do have to depend on the whole platform because we're using just the conditional editors. That's correct. All right. Thank you for your attention.